Either we are alone in the vast universe, or we are not. Well, both are equally terrifying. There are millions and billions of galaxies in the observable universe, and according to NASA chief Jared Isaacman, they are likely to find something that suggests life beyond Earth might actually exist. So, are we alone in the universe? Or is something out there already looking back at us? Before we answer that question, let's first understand the theory of life. Without a doubt, our universe is infinitely big. So, there are many possibilities that life is not only limited to Earth. But what actually is life? What does it need to even begin? From everything we've studied so far, life doesn't just appear anywhere. It needs very specific conditions, and the biggest one is liquid water. Every living thing we know, from the smallest microbes to humans, depends on it. That's why scientists focus so heavily on finding planets where water can exist. Not frozen, not evaporated, but stable. For that to happen, a planet has to sit in the right position around its star. If it's too close, the heat destroys everything. If it's too far, it turns into a frozen world. This region is known as the habitable zone, but even that doesn't guarantee anything. The star itself plays a role. Some stars are too aggressive, constantly blasting radiation that can strip away a planet's atmosphere before life even has a chance. Others might not provide enough energy to support the chemistry needed for life to form. This is exactly what researchers at the Center for Astrophysics, Harvard and Smithsonian are trying to understand. They study how life began on Earth. She build models to read the chemical makeup of distant atmospheres and develop instruments capable of detecting those signals across space. Missions like the Transiting Exoplanet Survey Satellite and the Kepler Space Telescope use what's called the transit method, watching for pretty tiny dips in starlight when a planet passes in front of its star. That small drop in light has already led to the discovery of thousands of planets, and the number keeps growing. In 2025, NASA confirmed over 6,000 exoplanets, with more than 8,000 additional candidates still under study. These aren't all the same. Some are massive gas giants, some are rocky super-Earths, and a few are very similar to our own planet. Astronomers believe there are billions of planets in the Milky Way alone, which means what we've found so far is only a tiny fraction. But out of all these worlds, around 1.3% are estimated to have conditions where water might exist. That may sound small, but on a cosmic scale, it's not small at all. With new technology like the Giant Magellan Telescope and instruments like GCLEF being developed by scientists like Juliana Garcia Mejia, we're moving closer to analyzing the atmospheres of these distant planets in detail. And once we reach that point, the question won't be whether life is possible. It'll be whether it's already out there. Hope one day we might find those green little creatures. Where is everybody? The Fermi Paradox. The universe might be enormously big, but if you look at it, it's almost unsettling how quiet it feels. And that silence has a name, and it's called the Fermi Paradox. In 1950, during a lunch conversation, when Enrico Fermi asked a question that stuck, "Where is everybody?" He wasn't trying to be dramatic. He was pointing at something that didn't add up. The universe has been around for billions of years. Even if a civilization moved slowly, that's still more than enough time to spread, explore, or leave some kind of trace behind. But when we look out, there's nothing we can confirm. That gap between what should be possible and what we actually see is what bothers scientists. One way people explain it is by saying, maybe intelligent life just isn't common. Maybe it's incredibly rare, or maybe it doesn't last very long. That's where the idea of the great filter comes in. Somewhere between simple life and advanced civilization, something stops the process. It could be early, like life never really getting started, or much later, when a species becomes advanced enough to wipe itself out. That leaves a strange question hanging. Have we already passed that point? Or are we heading toward it? Well, Nick Bostrom brought up something unsettling about this. If we ever find even basic life on another planet, like microbes on Mars, it might not be comforting. It could mean life forms easily, but almost never survives long enough to reach intelligence. In that case, the silence isn't random. It's a pattern. Of course, not everyone sees it that way. Some think life could be out there, just not in a way we recognize. Maybe the signals don't reach us. Maybe they use methods we haven't figured out yet. Or maybe the difference between us and them is so wide that communication doesn't even cross paths. Michio Kaku once compared it to the way humans relate to ants. We don't try to talk to them, well, not because they aren't there, but because the gap is simply too large. There's also a more cautious view. Stephen Hawking warned that trying to announce ourselves might not be the best idea. Carl Sagan raised similar concerns. In a place this vast, it's hard to know what kind of attention you might attract. Meanwhile, the search keeps going. Thousands of planets have already been found, many sitting in the right conditions for life. The tools are improving, the data is getting better, but the result hasn't changed. So far, everything we know about life still points back here, and that silence hasn't explained itself yet, and maybe will never. So, are we actually alone in the universe? Now, trying to calculate the probability that extraterrestrial life exists in the universe is very hard and complicated. Well, that's because the universe isn't a static place. Stars and galaxies are born, they live, and then they die. Some stars form with planets, others don't. And even when planets do exist, only a few of them sit in conditions where life could even begin. Then it gets even messier. Some of those planets might only form basic organic molecules. Some might develop simple, single-celled life. A few might go further and produce complex organisms. And in very rare cases, life might become intelligent enough to build technology, send signals, or even try to explore space. But even then, nothing lasts forever. On Earth alone, entire species have vanished for some unknown reasons. Civilizations have risen and collapsed. So, when you ask, how many advanced civilizations are out there? You're really asking a chain of smaller, uncertain questions. That's exactly what the genius Frank Drake tried to deal with back in 1961. Instead of guessing blindly, he wrote down an equation, now known as the Drake equation. He didn't write it to get a perfect answer, but to break the problem into pieces. Things like how often stars form, how many of those stars have planets, how many of those planets could support life, how often life actually starts, and how often it becomes intelligent. Then comes a crucial part, how long such a civilization remains detectable. That last part is where everything starts to wobble. We have a rough idea about star formation. In a galaxy like ours, new stars form at a rate of about 4 per year. Some estimates suggest that maybe half of those stars have planets. From there, the guesses get softer. Out of several planets, maybe only a fraction is Earth-like. Out of those, only some develop life. And out of those, only a few might ever reach intelligence. Even if you stay conservative with the numbers, you still don't end up with 0. Early calculations gave very high results. Drake himself estimated around 10,000 detectable civilizations in the Milky Way. Carl Sagan went even further and suggested the number could be closer to 1 million. That kind of thinking is what fueled early projects like SETI, the search for extraterrestrial intelligence. But decades passed, and nothing solid showed up. That forced people to rethink the numbers. Some scientists, like Paul Horowitz, brought the estimates down to around 1,000 civilizations. None others went even further. In 2002, Michael Shermer looked at human history and argued that civilizations might not stay detectable for long. His estimates suggested a civilization might only last a few hundred years in a detectable state. If that's true, the number of civilizations we could actually detect right now drops sharply. In some cases, it falls close to 1, or even less, which brings the whole question back to where we started. Even with all the math, all the models, and all the observations, we still don't have a clear answer. The equation doesn't solve the mystery, it just shows you how many things have to go right for us not to be alone. And maybe that's the real takeaway. What do you say? Let us know. Possibility of life on K2-18b. Well, we have no clear idea whether we are alone or not in the universe. But recently, a planet called K2-18b has brought that question back into focus in a serious way. It sits about 120 light-years from Earth, orbiting a small red dwarf star. Since its discovery in 2015 by the Kepler Space Telescope, scientists have been trying to figure out what kind of world it actually is. The real shift came when observations were made using the James Webb. A research team led by Niku Madhusudan analyzed the planet's atmosphere using transmission spectroscopy, basically studying how starlight changes as it passes through the gases surrounding the planet. What they found wasn't expected. The data pointed toward the possible presence of dimethyl sulfide, known as DMS, along with a related compound called DMDS. On Earth, DMS is not something you find floating around without a reason. It's produced by life, mainly by marine microorganisms like phytoplankton. That's why this matters. Not because it proves anything, but because it's the kind of chemical scientists have been hoping to detect somewhere else. K2-18b itself is already unusual. Some researchers describe it as a Hygiene world, a type of planet larger than Earth but smaller than Neptune, with a hydrogen-rich atmosphere and possibly a global ocean underneath. If that model is correct, then you're looking at an entirely different kind of environment where life could exist, not like Earth, but still based on water. But nothing here is settled. There are reasons to be careful. Earlier observations of the same planet suggested methane and carbon dioxide, but later studies questioned those results. Even now, the DMS signal is being debated. Other teams are analyzing the same data, so trying to confirm whether the signal is real or if it's being misread. There's also another issue. Even if DMS is present, it doesn't automatically mean life is there. Small traces of similar compounds have been found in comets and interstellar space. That suggests nature might have ways of producing it without biology, even if those amounts are far smaller than what's being reported here. So right now, this isn't a discovery, it's a possibility being tested. We're getting close to answers. Well, we hope you found this video fascinating. If you did, be sure to give it a like, share it, and hit that subscribe button. Thanks for staying till the end, and we'll see you soon.